Hello, this is Damian Kirk, back with part 7 of my series of videos on my Minecraft processor. This next part isn't quite about the processor in a sense, but since this is all running pretty simplistically, there's no operating system on this, obviously. No such thing as a system call, but this is kind of the closest thing to that, where there's a command that you specify a register, and it sends it out to here to be printed out on a sign over there, using totally separate hardware in a process that runs parallel to everything else. So first, let's take a look at how we're determining what actually goes into the printing hardware. These lines are coming from read register 1, and each one of them is being split off right here. You can see right here, each one of these goes into a repeater. It goes up and down, and the signal that goes down just stays as itself, just stays the same. The signal that goes up, though, goes into this XOR gate and this other XOR gate, or this series of half adders. So what's happening here is it's going into the XOR gate, and what's being XORed with all of these is, hold on just a second. Actually, it's this. In this case, it's the same one, but this is the most significant bit, and it's being XORed with all of these numbers. So if the most significant bit is 1, that means that the value stored here is negative, and in this, so this is what this is basically doing is on top it's generating the absolute value of whatever the number is. So if this number is negative, then this bit will be on. It will flip all the other bits, and then go into this level, which is just kind of a series of half adders that also is fed into by that most significant bit on the right. So it basically is just saying, it's basically flipping all the bits here and then adding 1. And unfortunately I couldn't come up with a more compact way to do this, but flips all the bits and adds 1 if the most significant bit is 1. If the most significant bit is 0, then the number is already positive. It doesn't XOR with anything, and it doesn't add anything, so the number just comes out the same anyway. But then that goes down here to these, which are the multiplexers, and these get selected by bit, I think it's bit 9, it's the bit after the opcode in the register is specified. So if you have a 0 there, it will select this version on top, which is the signed version. So if you have a negative number, it'll actually print it as negative. And if you specify it as 1, if you have the mode set as 1, then it'll just take the value that's on the bottom and treat it as unsigned. If you take the unsigned value, it will, instead of just going up to 127, it will go up as high as 255. So if you are just adding numbers up and you want to be able to go above the normal limit, you can use them as unsigned. But keep in mind that the processor will treat numbers as signed when you're doing things like set less than. So you have to be careful with using numbers as unsigned. So anyway, the value that gets sent out of these, oh, I should also, where is it? It's over here. That most significant bit from the original read is also sent over here. And if it's 1 and this bit is 0, which means we're doing the signed version, and it's a negative number, then this value gets sent down there, and we will, I'll talk about what that does in a little bit, but basically that's just telling the sign whether it needs to have the negative little minus symbol turned on. So anyway, these values coming out of the multiplexer go along these lines and end up over here. And this whole setup is what actually determines what's being printed. So the value comes down into here, and this gets a little bit convoluted just to even try to look at, but let's take the example of the first one down here. So basically this is similar to what I had for the program counter, where you have D latches storing a value and a series of full adders, which are right here along the back, and they're taking the value from the D latches and feeding their value back into them. So every time the clock pulses, it updates the value in the latches to whatever's coming through these adders. And whatever's coming through these adders is that number plus whatever's coming in the other sides of the adders. In this case, what I have in these adders is -10 on the other side. So every time the clock pulses, it should subtract 10 from whatever's in there. if the adder's value is being selected, and this is where it gets a little weird. So we have two signals to kind of select what is actually being fed into the D latches. If this signal is, wait, okay, I can't see very well. If this signal is on, coming from this side, it will actually block the signal from the adders. So if that signal is on, then no matter what is coming out of the adders, the clock will pulse and it'll register as 0. And there's this other signal here. If this signal is on, it will allow the signal coming in from the other side, which is the actual values here. So what happens is these values coming in will be ready to be loaded into these registers. And then down here we have a signal, let's see, this is the signal that's coming from the clock and print control signal. So this is saying it's time to print. And this will activate both of these lines. That line will block the value from the adders, so it doesn't matter what's coming in the adders. This value will allow through the value that's coming in here, and then down here it'll go to this, it'll pulse and activate all these clocks. So what that does is it says no matter what's coming through the full adders, just load whatever is coming in through these lines into the D latches and then proceed from there. So once that's happened, oh, I should point out that this line that blocks the adders is also used with the clear button. When you hit the clear button, it will send that signal to this one and all the ones down there, and it will also activate all the clocks, so it'll load 0 because it's blocking the signal from the adders and not allowing the signal from the registers. And that's how you clear it out and make it all 0. Anyway, once that value has been loaded in, we need to talk about this. This is a little, oh man, okay, this is annoying. Okay, so we need to cover this next. This is a little clock, similar setup to what I had for the clock from the main processor. It turns on, sends a signal around, it turns itself off, and it just cycles like that. But right now it's being held in an off state by this signal. And this is the negation of the carry out of the most significant bit. I'm not going to get into all the math behind why that is always correct, but basically what this is doing is saying if the result of the addition here is negative, then stop, because we're already at a point, because what's loaded in here is, on the left side of all these adders, is -10. So if subtracting 10 would make this negative, then stop the clock. And what the clock does is it just pulses every time, and it sends a signal to the clock inputs of the latches. So every time this clock goes around, it subtracts 10 from the number that's loaded in there. Once it's subtracted to the point where the value is less than 10, then subtracting 10 again would make the value negative. This will turn on and stop the clock. So basically, this whole setup takes in the number and then takes that value mod 10 and leaves it in the last 4 bits over here, because that's as high as you can go with mod 10. This clock also, every time it pulses, sends a pulse over here. Now this is the second set of latches and adders, and again it has this signal that'll block the value from the adders. But this signal is coming from this thing which is holding this clock off. So as long as this is off, this is going to be a little bit different. So this is coming in the left side here. When this is on, this is the same as over there. It's -10 on the left side, so it'll be subtracting 10. So whenever this is stopped, this will be acting as the same thing. When this is off, which means this is running, these values are going to be different. This is just going to be adding 1. And it's going to be pulsing every time this subtracts 10. So every time you subtract 10 over here, you add 1 to this, which means that this is going to end up being whatever this number is divided by 10. Then this will stop, this line will turn on, make this value -10, and it will allow the clock over here to run similarly, and subtract 10, so you then mod the next place by 10. So if you were to put, say, 107 into this first set of latches, it would subtract 10 times, and you'd end up with 7 over here and 10 here. Then this clock would run just once. You'd get 0 over here, and 1 over here. And there's another set of these, and this is only two bits because the highest value you can get is 255, and you only need 2 bits for the hundreds place. But it's the same basic idea, and this one doesn't have any of that subtraction hardware because it's really not necessary. But this just adds 1 every time it gets a pulse from this clock. So what you end up with is the big one down there has the value that would be in the ones place. The one in the middle gets the value in the tens place, and the value here gets the value in the hundreds place. And it's just a way of taking the base 2 number and kind of breaking it out into base 10. Then the signals from the 4 least significant bits of each one, or both the bits of the one over there, get sent into these, which are signs, and they do have to kind of be crossed. Like these values have to go to the one on that side, the middle ones go here, and the ones from the far left facing this way go to the ones on the far right. But that's just for being able to read it correctly. These are 7-segment displays. They're a little bit less elegant and kind of messier. You can see they're a lot taller here than the design that I had for my CS210 project last year, but they are more compact horizontally, so I can fit them next to each other, and they're faster. So the values, it's just combinational logic basically. They get 4 bits, and then you have the same ladder structure here that I use for everything else. And then there's different combinational logic that says, in this case, should the segment be on, yes or no? And right now you can see they're all on. They all have 0. Another way that this differs from my other 7-segment display is that it doesn't use hexadecimal characters. So I just did the simplest case to get the digits 0 through 9. So in the combinations that aren't any of those digits that can go in here, it's just kind of other nonsense. Some of them look like the same digits. Some of them look kind of close. Some of them are just random nonsense. But this this minus symbol, the sign over here, is what I was talking about before. So this latch gets the value that I was talking about before that was the most significant bit from the register, and if we're doing the signed version, that goes in down here. It can be blocked by the clear signal still, but it goes in down here to this latch, and then it gives a clock signal just like the rest of them do, and then that value is sent into the sign over here. So that's just the way to show things as negative. And this thing on the far right is just, it's just there to, since all the subtraction and modding and everything takes a lot of time, this is only on when it's not processing. So when you print out a number, this will turn off while it's kind of flipping the segments around, and then it'll turn back on when it's correct. And this is basically just a line that's saying if neither of the clocks that are doing subtraction are running at the time, it'll be on. So that'll turn off when you print a number, and it'll turn back on when it's done printing. I think that pretty much covers everything for the printing hardware. Tune in next time. Keep watching for my last video in this series where I'll talk about actual programming and maybe run an example program. Hopefully that'll be heavily edited because it's a little boring to watch it just run. But just show you what's going on kind of behind the scenes, and maybe an example of printing and watching how the numbers, how everything moves around. Yeah, thanks for watching.